Okay, we're going to be looking at Unit 15, equations and graphs. Obviously, a test that most people struggle with. This is the type of topic that's going to get you that grade 8, that grade 9, those top grades. So we need to be getting this right in order to achieve those types of top grades that I know so many of you want. So without further ado, I guess let's go into this. Great. By drawing suitable graphs, find an estimate for the solution to this pair of simultaneous equations. So we've got a graphical simultaneous equation. So we need to know what these graphs look like. This first one, I see x squared plus y squared equals 16. I am instantly thinking, as soon as I see x squared plus y squared, I know that x squared plus y squared is equal to r squared. That is the equation of a circle. So if r squared is 16, that means that the radius has to be 4. So I'm going to draw a circle of radius 4. If you look conveniently, that the kind of bars, I guess, that we've got 4 across in every direction. It's like 8 by 8, which is going to make life a little bit easier when it comes to doing a circle. So we can just draw a nice circle around. Obviously, use a compass in your exam. I've got the calculator, computer to help me. Like so. And plonk that there. A little bit bigger. Perfect. Okay. So that's a circle of radius 4. 1, 2, 3, 4. It needs to be a little bit to the left, but you get the idea. Always tough when it starts locking on. So that is my circle of radius 4. I can then change this graph into the form y equals mx plus c. You don't technically need to, but I like to. So we can get 4y is equal to minus x plus 5. And then dividing by 4, y is minus a quarter x plus 5 over 4. 1, 2, 3, 4. So we know it's got a y-intercept of 1.25. 1.25 is here. And each 1 square right goes a quarter down. So if it's at 1.25 at 0, at 1 it's going to be at 0. It's going to be at 1. Here it's going to be 7.5. At 3 it's going to be 0.5. And at 4 it's going to be like 0.25. Which is that. Which kind of looks like it intersects with the circle. I can then draw a straight line going through those points. Like so. And now I've got 2 coordinates here that I can just write down the values of. Okay, got one there and one section there. That to me looks like, 4, 0.25. So my first one I'm going to write down as 4, 0.25. Once again, you can get a range of values, so that's not a problem. And my second one is going to be, shouldn't write those as coordinates, obviously, because these are solutions, not necessarily coordinates. When x is 4, y is 0.25, and when x is, what's that look like, minus 3.4, is that? Minus 3, minus 3.1, 3.2, 3.3, 3.4, it looks like 2.15, 2.1, something like that. So when x is minus 3.4, y is minus 2.1. Okay, perfect. Right, this one showing the working, well, this first one is going to be a U shape, and it has a y-intercept of 4. So let's see if there's a U shape that has a y-intercept of 4. And if there's only one, then we've got our answer. This has a y-intercept of 4, C. I don't think any of the others do. So A must be C. This one here is going to have roots at 3 and minus 1. So is there a graph that has roots at 3 and minus 1? Yep, there is, and that is A. So B is A. This one is minus x squared, meaning it's going to have to be an N shape. So C is B. And this one here is obviously going to have to be the last one left. If you wanted to use this one, we can see that there's going to be a turning point at 2 minus 3. Okay, to make this bracket here 0, x needs to be 2 because we have 2 minus x. So 2 minus 3, once again, you can see that one's here, so it is, in fact, D. Okay. Right. We want to draw minus 10 to 10. I'm going to assume it splits nicely in half, because why would it not? And there's minus 10, 10. Is that halfway? Potentially. We'll find out. I think that might be halfway there. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That works. 10, 9, 8, 7, 6, 5. Only mark on every 5. Just save yourself a bit of time. 2, 3, 4, 5, 6, 7, 8, 9, 10. And same in the negative direction. A lot of this was just kind of being able to draw graphs. So I guess I'll fill up the space with just needless waffle. 3, 4, minus 5, minus 6, minus 7, minus... Why am I writing on minus 6, minus 7? No one knows. After I just said don't do that. And minus 10. Okay, always nice to label our axes. This is the y-axis. And this here is the x-axis. And we are asked to draw or shade the region that satisfies y is y minus 2x is less than 7. Straight away, I don't like the look of this, so let's turn this into y is less than 2x plus 7. So I can put a mark at 7 here. 1 right, 2 up. Obviously, I'm already off the page, so 1 left, 2 down. 1 left, 2 down. So on and so forth. And then we can just draw a straight line. Kind of goes through all of these using a ruler, obviously. Something like that will do. Okay. Now, since we are less than that, I need to make sure that this here is a dashed line. Okay. Because it is only less than, it's not less than or equal to, it's that. And since we have y is less than, then I know I am going to be below this line. So I'm somewhere below that dash line. Y is greater than 4. So same thing. I'm going to do a dash line going horizontally at y is equal to 4. Since it's not equal to, it's just greater than 4. That is there. And since we have y is greater than 4, I must be above this line. So I'm looking for where I'm below the diagonal line and above the horizontal line. And that is this entire section here. Okay, and it kind of keeps going and going, right? If I drew the graph bigger, it'd be all this area over here. But we don't have that, so we'll just leave it like that. Okay, you don't have to shade every little detail as long as I get the rough idea. Right, question 4. Expand the expression this. Most people got that right, so let's go nice and quick. We're going to first expand the first bracket, x squared plus x minus 12. X minus 2, and then expanding that bracket, we get x cubed minus 2x squared plus x squared minus 2x minus 12 plus 24. So let's just quickly make sure that that simplifies to x cubed minus x squared minus 14. So that should have an x there, 14x plus 24. Okay. B, since we have a power of 3, we know it is a cubic graph. Solutions to the equations are going to be at x is 3, x is minus 4, and x is 2. Since I am looking for solutions, I should be writing down x equals just to show that those are in fact my solutions. And finally, where does the graph intersect the y-axis? Well, its y-intercept you can see here is at 24. So you can say 0, 24 or just 24. Nice easy question, I think. Sketching the graph, we need a couple of things to sketch a graph. We should mark on the y-intercept, the turning point, and roots, though you don't really need to do the roots if they're horrible. If the roots are nice, whole numbers, fractions, fine. If they're horrible, you don't need them. I'm going to put them on, but technically you don't need them for this question. Okay, we're going to just draw a nice little axis like that. We can already tell it's going to have a y-intercept of -1. So I can put -1 on there. We know it's got some kind of u shape because it's x squared. So let's find the turning point first of all. It's going to be y is equal to x minus 2. So we're completing the square. Squared minus 4 minus 1. So that's x minus 2 squared minus 5. So that's got a turning point at 2 minus 5. So 2 minus 5 is going to obviously be somewhere over here. So I can put that on there, and let's mark that 2 minus 5. Once again, it doesn't have to be super accurate. I'm now going to find the roots. This does not seem to factorize. I've not been able to do it in my head while I've been talking. So I'm going to assume I need to complete the square. Not complete the square. Quadratic formula. So I can say x is equal to 4 plus or minus the square root of minus 4 squared minus 4 times 1 times 1. Sorry, minus 1 on the end. All over 2 times 1. Let's just type that in my calculator. 4 plus the square root, 16, plus 4, all over 2. I get 1 root at 2 plus the square root of 5, which is at 4.23. This is 4.24, let's say, to 1 decimal place. And I get my second root at 2 minus root 5 minus 0.23. Minus 0.234. Okay, or minus 0.24. Okay. If you notice that this here is the middle of the points, if you add these together, divide by 2, you get 2. Because obviously it's symmetrical. Now a nice just smooth U shape. This is the turning point, meaning it's going to have to turn around there and then go back up. Something like that. Okay. As long as it looks somewhat accurate and you've labelled these points, you're fine. Once again, since these are horrible decimal numbers, not actually essential. Right, equation with a maximum point. So since it's a maximum point, it's going to have to look like that, meaning it needs to be minus x squared. So I'm just going to write minus. Now, if I want the turning point at 3, I need to do x minus 3 in my brackets, and then minus 4 outside the brackets. And that's it. It doesn't ask me to do anything fancier than that. It doesn't ask me to write in a specific way. It just asks me to write an equation. Like, you could expand it, but it's not asked you to, so why are you? Because you might just make a mistake in your expansion. It's not needed. Right, exact area determined by the inequalities. Once again, I see this thing here that is instantly thinking x squared plus y squared is equal to r squared. So once again, I am thinking about this. This is a circle with radius 5, so I'm going to draw a quick little graph. Like that. Nothing too accurate, right? Nothing too accurate. There's 5, minus 5, and minus 5, okay? Once again, because technically it is, well, it's greater than or equal to, so I do want a full line, okay? Since we have greater than this, it means we are going to be on the outside of the circle. Hopefully that makes sense. So I know I need to be on the outside of the circle, okay? Just remember those other things. We should have x is greater than 0 and y is greater than or equal to 0, okay? So, since I've got that x is less than or equal to 5, let's draw a line at x is 5. That is here. And since x is less than or equal to 5, I want to be to the left here. And since I've got y is less than or equal to 5, I'm going to draw a horizontal line here. And I'm below this green line. So at the moment I'm on outside of the circle. I am below the green line and I'm to the left of the blue line. Technically that includes all of this stuff as well, which is why I needed that whole greater than or equal to 0. So I'm also, if you think, to over here and over here, meaning that the only region I care about is this section here. Okay. Well, this whole thing is a 5 by 5 square. This section is a quarter of a circle. So if I do the area of the circle, or like the quarter circle, minus from the area of the square, I'll be fine. So area square is 5 by 5. So 5 times 5, which is 25. Similarly, area quarter circle, like this section here, no, quarter, is going to be, well, it's going to be pi times r squared. We know that r squared is 25 already from before. So pi times 25, and then it's going to be a quarter of that, which is just 25 over 4 pi, like so. So the area shaded must be 25 minus 25 over 4 pi. Since it says leave your answer or give the exact area, we're just going to leave our answer like this. We're not going to turn it into a decimal because then that's not exact. There will be some kind of rounding. So just leave it like this and it is in exact form. Okay, if it ever says exact, leave it like that. Right. A is the graph of this and B is the graph of this. So I have two graphs that are intersecting. I'm not even seeing what's going on here yet. There are two graphs intersecting. I am thinking this is simultaneous equations. So I've got y is equal to x squared minus 3x plus 5. This one I can rearrange to y is equal to x plus 5. So x plus 5 is equal to x squared minus 3x plus 5. Setting them equal to each other. If y is equal to this and y is equal to this, then I am fine. I can now subtract 5 and x from both sides to get 0 is equal to x squared minus 4x. Well, plus 0, 5 take away 5 is 0. Now we have to be careful here. We have a quadratic. Remember, when we solve a quadratic, we factorize. Factorize means taking out what is in common. So I'm going to take out what's in common, which is x in this case, x minus 4. That's going to give me two possible solutions. Either x is 0 or x is 4. I can now sub these points here into this graph here. So I can say when x is 0, y is going to be 5. And when x is 4, y is going to be 9. If you want to be really safe about your answer here, you can now sub both of these into this one here and see if you get the same. Okay, so if I do 0 squared plus or minus 3 times 0 plus 5, I still get 5, so that one worked. And if I do 4 squared minus 3 lots of 4 plus 5, I still get 9, so that one also worked. So you can sub it in and see if it matches. If it matches, that must mean they meet there. Okay. What effectively this means is I've got a graph that looks something like this. So I've got like a point here and a point here. This is 0, 5. This is 4, 9. And I'm trying to find the distance. Well, I've gone 4 across and 4 up. So we can do a bit of Pythagoras. Square root of 4 squared plus 4 squared is going to be root 32, which I can now simplify. If you imagine this is 2, this is, sorry, what am I thinking? 16 times 2, so 4 root 2, because that's equal to root 16 times 2. Perfect. We're getting there. Right. Classic question. We're going to factorize it. Hope it factorizes anyway. As soon as we see a quadratic and we've got a 0 on the right, I guess we factorize. X plus 3, x minus 2 is greater than 0. Once again, what this tells us is we've got a graph that looks like this. We've got a root at minus 3. And we've got a root at 2. So we've got a shape that looks like this. We know it's a U shape because it's positive x squared. And we're looking for where this graph here is above 0. So you can see that this section here is above 0 and this section here is above 0. Now how I would describe this to someone, well, this section on the left here is to the left of 3. So we've got x is less than minus 3. And this section on the right here is when to the right of 2, and I would describe that as x is greater than 2. Since they are disconnected sections, we're going to use the word or. Okay, so x is either less than -3 or x is greater than 2. Once again, you could choose a number for both of these and see that it works. If I choose 5, for example, 5 squared is 25, 25 plus 5 is 30, 30 take away 6 is 24, 24 is greater than 0, so that works. Similarly, I could put a negative number below 3 in, -3 in, and see if that works. Right, real roots. We can't just check for factorizing because quadratic formula might work. So what we need to do is we need to check that whole square root part. The only part of the quadratic formula that can mess up is the square root, yeah? Why? Well, we can't square root a negative. So if this part here is wrong, then we've got a problem. So we just need to check whether b squared minus 4ac is positive or negative. If it's positive, we have real roots, and if it's negative, we don't have real roots. So for a, if I do minus 6 squared, minus 4 lots of 1 times 13, that's going to get me 36 minus 4 times 13 minus 16. Okay? Since this is negative, as negative, no real roots. No real roots. Okay? There are roots, but they aren't real roots. You'll talk about that if you do further maths. Right, same idea for the next one. We can do 4 squared minus 4, 4 times 2 times minus 5. 16 minus 8 times minus 5 is 56. So yes, positive. So real roots. And same idea for the final one. We're going to do minus 4 squared minus 4 times minus 1 times 9. You should be able to tell that this is positive already because we're going to get 16 plus something. But let's just do it. 16 plus 36 is 52. And once again, positive. So it has real roots. This is what you want to be thinking as you do this. Oops. Okay. We don't care what the roots are. You could obviously show them, but this will do. As once again, we are just showing that this part here is the only thing that matters. And if it's positive, we have real roots. Negative, we don't have real roots. Excuse me. Okay. M is an integer such that n squared plus 8 over 9m is less than or equal to 1, and 3m minus 4 is greater than 11. Since we've only got one unknown, these aren't really simultaneous equations. I'm just going to solve the two separately. M squared plus 8 is less than or equal to 9m. So n squared minus 9m plus 8 is less than or equal to 1. So n squared minus, not 1, 0. What am I doing? 0. I can now factorize this. M minus 8, m minus 1 is less than or equal to 0. Since this is a quadratic, once again, it looks something like this. We're going to have roots at 8 and 1, so the other side. Something like that. That's at 1. That's at 8. And we're looking for when this graph is below 0. You can see that the graph is below 0 here. Since it's a connected inequality, like the region is connected, I can just say that 1 is less than or equal to m is less than or equal to 8, aka our value of m is somewhere between 1 and 8. Okay, any of those numbers. Similarly, doing the part on the right, 3m minus 4 is greater than 11, so 3m is greater than 15, so m is greater than 5. So now using these two combined, I know m is any number between 1 and 8, inclusive, includes 1 and 8, whereas m has to be bigger than 5. So m can't be 1, 2, 3, or 4, or 5, because that's not bigger than 5. So the only numbers that m can be is 6, 7, or 8. Okay, they're the only numbers that satisfy both inequalities at the same time. Right, a nice bit of iteration. Remember, just type minus 2.2 into your calculator, x1, and then type in the cube root of ans minus 8. So minus 2.2, cube root of ans minus 8, and I'm getting minus 2.168702885. Press equals again. X2 is minus 2.166482503, and x3 is minus 2.166324805. Okay. Then we are asked to explain the relationship. Okay. Now, the trick is the answer is going to be the same, but if you imagine if I've got like x is equal to the cube root of x minus 8, I could cube both sides, x cubed equals x minus 8, then moving everything to the right, I get, or left even, x cubed minus x plus 8 equals 0. So you can see actually that this thing here at the top is actually just a rearrangement of this one here. So that must mean that these are estimates for the solution. Okay, they are estimates to the solution a solution of the equation. Okay, because one's a rearrangement of another, they are estimates of solution to the equation x cubed minus x plus 8 equals 0. Okay, right, almost done. One last question. Two broadband providers offer the same tariffs. No monthly cost, 2 GB per gigabyte of data. Monthly tariff £20, 1.5 GB of data. So why is total monthly cost? So for online, it's going to be y is equal to 2x, and for stream speed, it's going to be y is equal to 1.50x plus 20. Obviously, you don't need to write 1.50. We are then asked to use a graphical method. So I guess we draw ourselves a nice little graph. Don't know why you'd use a graphical method to find out when they're equal, but here we are. Okay, let's try in 10. I'm going to assume it's high, just looking at the numbers, 10, 20, 30. Roughly space them out equally, 50, so on and so forth, 0, 10, 20, 30, 40, 50, so on and so forth. Let's make this a bit taller, just in case. 16. Right, we know for online, at 0 it's 0, at 10 it's 20, at 20 it's 40, so on and so forth. So I get a line that looks something like that. You can see that the scale's slightly off. Something like that. And for the other one, it's 1.5 plus 20, so at 20 it's there. At 10 it's going to be at 35. At 20 it's going to be at 50. 50, yeah. Okay, at 30 it's going to be 40, 70. You can see it's going to be something like that. Oh my goodness. They're going to touch somewhere over here, which kind of looks like actually it's at 40, right? You can imagine them touching there. If I extend this a bit further, and I extend this a bit further. I don't know why we're asked to do it this way, but we're asked to do it this way, so I guess this is how we're doing it. Just ask for graph paper in the exam, I guess. I'm going to say they touch at 40, so when x is 40, part B, when x equals 40. And then you are asked when stream speed is cheaper. Well, stream speed is this line here. So you can see that the green line costs less when it's past 40. so past 40 gigabytes of data. Don't know who the heck is using 40 gigabytes of data, but here we are. All right, hopefully that's it. Obviously, if you've got any more questions, please let me know. Feel free to, do whatever you want. Ta-ra!